Hello. Let's begin our class. Quiz results were updated, and you can take a look. And the accuracy results of assignment 1 also updated. And the deadline of assignment 1 is today. So the deadline is 12 p.m. If your accuracy is 0, you still have chance to fix it. If your assignment's accuracy is 0, this means your program output does not follow the assignment requirements. Your program output should be exactly the same as the examples given in the assignment 1. So this means you cannot output extra line breaks. I saw some students output extra line new lines. For example, I saw students output line breaks after this line. After this line, there is no line break. After cout, we use cin to read. We read user input into the variable slice, and there is no line break between cin and cout, so you cannot output a line break. And I also saw that some students output additional line break before this line. He added a line break inside this string, and this is not required by this assignment. And another common mistake is omit this string. Many students omit to output this string, and this will cause your program output does not follow assignment 1's requirements. So the best way to finish assignment 1 is to begin with the code template, and it is recommended that you enter your code here and do not modify other parts. For example, you should not modify this string. You should not add any cout by yourself. You should not delete this line or output any other constants or other variables. The deadline is today, so you still have one chance to submit your assignment 1. And I posted assignment 2 yesterday. The deadline is 3 weeks later. The deadline is the day after the midterm. And the submission, you should follow the same rule to submit your assignment. I saw some students send links to the CPP file, but the submission rules require you to send real CPP files. This means you should download the CPP file into your computer, and when you send the email, you should attach the CPP file. And I will introduce assignment 2. Assignment 2 requires you to write a program that draws two letters Z or V in terms of some symbols. So here is one example. This is, your program should output this message, and then the user start to input three characters. Three characters. The first characters specify the letter you want to draw. So the first input is either Z or V. And this letter can be uppercase or lowercase. So for example, here I use lowercase, but you can also use uppercase. And the second input is an integer. And this integer specifies the height of the letter to be drawn. And the third input is the symbol you want to draw the letter. Here I use letter O, so you see that this letter is drawn by letter O. Here are some details. The input height is between 5 and 50, and you don't need to validate the inputs, so you don't need to perform a check for the height. This is for you to test your program. And the first input can be uppercase or lowercase. And I draw a figure to show how to output letter like this. So to draw letter Z, here I choose the star symbol. Here I choose the star symbol to draw this letter Z, and this letter is not inside the list, but you can replace the star with O or X or this symbol. So here star is the symbol we want to draw this letter. So and the user input Z 7 and the star. And here is the output of your program. So your program will output 7 rows. The first row is the first row contains 7 stars, and then followed by a light break. So the light blue grid represents a light break. After the light break, then your program outputs the second row. For the second row, you need to determine the number of spaces you want to print it. So for the second row, you need to count how many spaces you want to output. And after space is the star symbol. And after the star symbol, you output the light break. And after light break, the second row is finished. Then we continue to the third row. The third row you perform similar task. You output some spaces, followed by the star symbol, and followed by the line break. And then you continue this process to the 6th row. And the last row is the 7th row. For this row, you output 7 star symbols. So your program output should be like this figure. Suppose the input is Z7 star. And I will test your program with different height and different symbols. So your program should be very flexible. Your program should be able to deal with different heights and different symbols. Here is another example. For example, if height is 11 and the symbol is this one, then your program output should be like this. And I also provide one incorrect sample. You can see this figure. The left hand side is the correct one, while the right hand side is incorrect one. And you see that here the white grid means space, and the gray grid means nothing. So you should distinguish between space and the empty. Because empty, you output nothing. On the left hand side, after line break, you output nothing, and you go to the next row. However, on the right hand side, if you check the second row after the star, one additional space is printed. So you see on the right hand side, the second row contains one additional space. And for the third row, you notice that after the star symbol, 2 additional spaces are printed. And this is considered incorrect because the assignment does not require you to output additional spaces. So if your program outputs like right hand side, you will get accuracy 0. So here is you can copy the output in example 1 to any text editor, and you will find your program output should be like this. And you notice that when you move the cursor to the second row, the cursor is after the letter O. When you move your cursor to the third line, the cursor is also after letter O. But if you output additional space like this, if you output additional spaces, you will notice the cursor is remains the same horizontal position. So this is incorrect if your program output like this. So this looks like, so the left hand side and the right hand side looks identical because you cannot see a space. But the right hand side is incorrect because the right hand side outputs additional spaces. So this is the first letter. So you need to write some code to draw letter Z. The next letter is letter V. The inputs are similar. You input 3 characters. The first input specify letter V, and the second input specify the height of the letter you want to draw. The third input specify the symbol you want to use. Here I use letter X. So letter X is used to draw letter V. And you can see another example in the input-output samples. So here I use the input is V10, and the program output should be like this. The output contains 10 rows. And you can refer to the this figure about how to draw letter V. The user inputs V7, so the height is 7, and your program will output 7 rows. For the first row, you output the star symbol first, and then you need to output some spaces. You need to count how many spaces are required, and the number of spaces depends on the height. So you need to develop a formula about the number of spaces you want to print. So you will use a for loop to print a number of spaces. After spaces, you print the star symbol, and followed by a line break. So this is the first row, and for the second row, you do similar task, but you need to output some spaces between the first star symbol. Because if you want to draw letter V, for the left, for this line, you need to draw some spaces between before the first star symbol, and you also need to develop a formula for the number of spaces before the first star symbol, and this number also depends on the number of height. This number, the number of spaces depends on the row number. So your formula should be dependent on the row number. And after the first star, you print some spaces, and after that you print the star symbol and followed by a line break. And after the line break, this row is finished. Then you continue to the next row. So you will notice that the pattern for each row is similar. You print some spaces, then print the first star, and then you print some spaces, and then you print the second star symbol, and finally you print the line break. So this example is more difficult than the previous one because you need to print you need to print more. You need to perform more controls on how to on the number of spaces. Here is one incorrect samples. The left hand side is correct one, while the right hand side is incorrect. The right hand side is incorrect because the right hand side output additional spaces. You notice that the white grid means a space, while the dark gray means the gray grid means empty. And empty is different from a space. So on the right hand side, after the second star, additional spaces are printed. And this is not required by this assignment. So if your program outputs like right hand side, then your program does not follow assignment 2's instructions. You can copy the samples to some text editor. And you can move your cursor, and you will notice the cursor is right after the symbol. And for example 2, you cannot output additional space before the first symbol. For example, you cannot output your program output should not be like this. This has one space shift because you output additional space on the before the first symbol. So this is also considered incorrect. And you should also notice your program output, because sometimes I saw output like this. So this is also incorrect because it does not this does not match the assignment 2's description. So it is recommended that you use the code template to finish this assignment. So you don't need to type the input message by yourself. So you just only need to implement you just need to enter your code inside the case Z or case V. So you don't need to modify other parts. So for this code template, you see that this template uses the switch statement, and this statement can deal with uppercase Z or lowercase z. They are in the same block. And similarly, for lowercase v or uppercase v, they share the same statements. So this program can deal with both uppercase Z or lowercase z. And your program uh, has one constraint. Your program size should be less than 10k bytes. This means you cannot use copy and paste because the input range is finite. So the number of combinations is also finite. You can use copy and paste to generate all the possible answers. But this will make your program very huge. And so here is one constraint for your program. So this assignment is to practice how to use the for loops, and you need to use some if statements to determine when to print spaces, the symbol, the line break. So for this assignment is for you to practice how to use the flow control introduced in our slides. Next, we will have a quiz. And if you need to use answer paper, please raise your hand. Anyone need an answer paper? Anyone need an answer paper? And if you use laptop or tablet, you should close your laptop until the quiz is finished. For question 1, you need to read the question carefully. And here, you need to determine the value of sum after the above statements. 30 seconds left. The second question, you need to determine the value of sum after the above statements. Uh, 30 seconds left. Next, I turn on the third question. For the third question, you need to determine the sum after the above statements. 30 seconds left. Time is up, so I will turn off all the questions. And if you use answer paper, remember to write down your student ID and your name and submit your answer paper to me. Or anyone use the answer paper? And let's see the answers. For question 1, the answer is option 3. And if you choose option 2, this means you do not read the question carefully. For this question, the initial value of sum is 10. So if your answer is 28, this means you forget to add the initial value. So for this example, is very basic. This is a basic example for the for loops. You need to trace the value of n in each iteration. So the value of n is 1 in the first iteration, and becomes 5 in the second iteration, and becomes 9 and 13. And after 13, when n becomes 17, this for loop terminates. So we only have 4 iterations, and in each iteration you sum, you add n to the variable sum. So we just sum the 4 numbers. So you see the answer is 28, but you need to add the initial value. So the answer of this question is 38. For the second question, the answer is unknown. The answer is unknown. Here we declare a variable sum, but we do not initialize. We do not initialize this variable. So its value is actually unknown. It's a some number, but we don't know its value. And after that, you perform some operations. You add some value to this variable, so its value is still unknown. And this is one common mistake for beginners. For not initialize a variable. This is a common mistake. So to correct this, you need to initialize this value to 0 in order to compute the sum of these numbers. So for this, for this question, the answer is unknown. For the third question, the answer is 20. I think most of you computer right answer. And this example use the continue statement. So you need to understand what does continue mean. You need to trace each iteration. So you need to trace the value of sum in each iteration. And here I can use a computer, but in the midterm or in the quiz you cannot use a computer. This here you need to trace the value by yourself. And we see that in the first iteration, the value of sum is 2, because here the value of sum is added by 1, and in this line, n is 1. So for the first iteration, sum is in this line is also added by 1. So after this line, the value of sum is 2 in the first iteration. And for the second iteration, this line increase the value of sum by 1, and this line increase the value of sum by 2, because in iteration 2 the value of n is 2. So after this line, the value of sum becomes 5. And for iteration 3, you perform similar operations. And when sorry, this 20. So and you perform similar operations. And, so for this example, after in the fourth iteration, we know here this line increase sum by 1. So 9 plus 1 is 10, and this line increase sum by 4. So 10 plus 4 is 14. Then if n is greater or equal to 5, the continue statement will be executed. And this means the program will skip the lines after the statements after continue. So the following 2 lines will be skipped when n is greater than or equal to 5. So you will not see any message after n is greater than or equal to 5. However, this line will be executed because the for loop continues. So in each iteration, the sum is increased by 1. So in iteration 5, sum is increased by 1. We can add additional cout statement. You can add additional cout statement here. So in each iteration, we print sum 2 times, and you can notice the value of sum. And in the 5th iteration, sum is 15, and in 6th iteration, sum is 16. So after iteration 5, sum is increased by 1. And finally, after the for loop, the value of sum is 20. So you need to trace the for loop by yourself. Any questions about the quiz? If no, oh, hello. Number 2. You mean the second question? Second question, okay. You want to know the value is unknown? Yeah, this is the rule of C++. If here we declare a variable, but we do not initialize this variable. What? Here we declare n only. It did not declare sum. Here the question only declares variable n. Yeah. Oh, okay. We can try. You can try. Here, if you so if you declare this variable without initialization, actually its value is unknown. Some computer will output 0. Some computer, because this value is depends on the value remained in your memory space. So this value is varies on different computers. So your computer might show 0, but according to the C++ rule, if you declare a variable without initialization, its value is unknown. Any other questions? I think time's up, so let's take a break for 10 minutes.
大家可以来前面拿自己的那个体检报告。Okay, I need your attention. I need your attention. Please come to the front to receive your own health report.
Hello. Let's continue our class. We will learn arrays in this chapter. An array means a container. A container is a collection of elements. And in C++, the elements are required to be the same data type. Here is one example. Suppose we want to declare 5 variables. Then you can use a statement like this to declare 5 variables. However, if you want to declare 100 variables, then it is tedious to write down each variable. So if you want to declare many variables at the same time, you can use array. And to declare array is similar to declare a variable. First, you write down the data type. This is the data type of the element in a container. And then you write a variable name. This is the name of the array. And followed by the array name, you add a bracket. This will tell the compiler you declares an array. And inside the bracket, you need to specify a number. This number represents the size of this array. The size means the number of elements in this array. So it is easy to declare 100 variables using array. So you change the array size to 100. And actually, array is built in C++. This means you do not need to include library in order to use arrays. And you have you have other choices. C++ has many containers. Array is a sequence containers. And we have other types of containers like associate containers such as set and the map. And in such container, each element is a key value pair. So this is different from what we will introduce. And later we will introduce other containers like vector in later chapters. And if you are interested in these containers, you can take another course like data structure. Data structure will teach you how to implement each container, such as the queue or list or stack. And so here is the figure for when you declare an array. So for example, when you declare an array of 6 elements, then you create then you tell the compiler you want a memory space of 6 integer elements. So each element is an integer. And here we do not initialize this array. So here I use a question mark to represent its initial value is unknown. And we will associate each element with index and the index always begins from 0. So if we have 6 elements, the index begins from 0, 1, 2, up to 5. So the index is at most size -1. And you can modify the value of each element by using index like this. For example, you want to modify the value of the element at index 3. Then you can use this syntax. You use ARR bracket, and inside the bracket you specify the index you want to modify. And here I assign 10 to this element. So the value at this index is replaced by 10. So in this way you can modify the value of each element. So one important factor to know about array is that the array is static. Static means you cannot modify its size. So you cannot delete or add any element for an array. So array is static. And this is different from dynamic array. So what we learn, an array is static. And if you want dynamic array means you can adjust its size. You can add or delete elements from this array. This is called dynamic array. So if you want to use dynamic array, you need to manually allocate memory, or you can choose to use the data type vector. This is defined in the STL. Vectors is a data type defined in C++ standard library. So later we will introduce dynamic array and vectors. The two data types are dynamic, which means you can adjust the array size. So here, when you declare this array, then its size is fixed. And I will show you some examples. So here I declare an array of 6 elements, and each element is an integer. So the total number of bytes is 6 times 4, because each size of int is 4 bytes. So the size of this array is 6 times 4 is 24. So this array occupies 24 bytes in memory. And because its size is fixed, so we usually use naming constants to denote the array size. So we usually we usually write code like we will use the naming constants like this. So here I declare a naming constant. A naming constant means you give a name to a constant. So initially you do not know what 6 means. 6 can be any number. So here we give a name. 6 means the number of students. So you can give a name to this constant. And here actually we just declare a variable. And we use the constant modifier. This modifier tells compiler this variable is read only. You cannot modify its value. So the variable is this variable is can be regarded as a constant. And we usually declare an array like this. And sometimes I saw some students, I will demonstrate the wrong way to declare an array. I saw some students write code like this. This is legal. The code is legal because you can compile. You can compile this array. You can compile this program. However, this is dangerous. This is because initially I do not initialize size. So its value is unknown. If the user do not input size, then this line you do not know how many elements inside this array. So you will see. So you will see that the program does not finish normally because size can be a negative number. So if you write program like this, this is very dangerous. So if you let array size to be a variable, this is very dangerous. Although it is legal, but this is very dangerous. We know static array. We know we cannot modify the size of a static array. So you should let its size to be a constant. So we declare array like this. The array size is always a constant, not a variable. So you see that this is very dangerous. Here I do not initialize size, so the value of size is unknown. It's some random number, and in this computer, its value is very large. And this means you try to declare an array with with many elements, and this exceeds the memory space of this computer. So the operating system cannot offer such memory space to your program, and therefore your program cannot finish normally. So this program finished with SC code other than 0. So it is very dangerous if you do not know the size of a static array. So do not write code like this. So I usually recommend that you use the naming constant to declare an array, or you can just specify a constant here. So here is another important thing to when using array. So you must ensure the index is within the legal range. The legal range is from 0 up to size -1. If you do not, if your program do not follow this rule, your program might lead to my code's runtime error. Here I will show some examples. So here I declare an array of 6 elements. Then I try to modify the element at index 6, and this will cause index out of range. Because the legal range is at the most 5, is at the most size -1, and if you perform this assignment, this is outside the legal range. So here cause a runtime error. You will see stack smashing detected, terminated. This is runtime error. On your program, different message might be printed, because this is depends on your programming environment, and sometimes no error message is shown. However, if the index is within the legal range, the program will finishes normally. Here, if I replace index with 5, then this assignment is within the legal range. So you notice that the program finishes normally. The SC code is 0. So, however, if your index is outside the legal range, you can still compile the program. This means the syntax is legal. So the compiler cannot detect index out of range for the static array, and you might encounter runtime error. And we can revisit what is runtime error. This is introduced in our first course. So we have two phases. The first phase is compile time. Compile time means the phase during the source code is converted to executable code. This is called compile time. And if an error is occurred during this phase, then the error is called compile time error. And we also have runtime. Runtime means the period when you run your program, when you run your compile program. So this is called runtime. And if an error occurs during this phase, then the error is called a runtime error. So for our example, we have a runtime error. I will show you some wrong examples about declaring array. I saw this example from students' assignments. So here are some wrong usages. I saw some students write code like this. So here I declare an array, and its size is determined by this variable, by the variable size. And however, the value of size is 0. So this means this array contains 0 elements. This means this array cannot be used. Because if you use index 0, this assumes the array has at least 1 element. So this will cause index out of range. But this program no runtime error shows. But this already this caused the index out of range. Sometimes this will not cause problem, but sometimes the program will crash. So we need to ensure the index is always within the legal range. So if you write code like this means you do not understand the built-in array is static. You might think you have chance to modify the array size. However, this is wrong. The static array, the built-in array is always static. If its initial size is 0, then the size is fixed to 0. You cannot modify its size. So do not declare a static array like this. So the next slide introduce how you can access array elements, and we already introduced you can use subscript. You can use index. Index is also called subscript. You can use index to access array elements. And now we have to distinguish two uses of brackets. So so when we declare an array, the number inside the bracket means the size of this array. However, in other situations other than declaration, the number inside the bracket means index. So the meaning are different depending on context. Only in declaration, the number inside the bracket means array size. Besides declaration, the number inside the bracket means index. So you need to distinguish the two scenarios. If you don't understand the scenario, your program might cause index out of range. For example, if you do not know the meaning of the number inside bracket, you might use 6 here because you think 6 because you want to because if you think you want to use this expression to denote the entire array. I saw some students want to send the entire array to some function, and he used expression like this. He specifies 6 inside the bracket. He thinks this can represent the entire array. However, this is wrong, because if your expression like this only refers to the element at the index 6. However, this element does not exist in the array because this calls index out of range. So if you cannot distinguish between the two contexts, the two scenarios, your program can cause index out of range. So here the slides remarks the meaning of the numbers inside brackets. And array is very common when programming. We always use array, especially for scientific computations. For scientific computations, you need to deal with matrix, high-dimensional arrays. So the usage of array is very common. And next, I will show you some common operations about array. So now I will show how we can initialize an array with a pair of braces. You can specify the elements in this array as its initial value. So here I specify 5 elements, 5 integers as the initial values of this array. Then suppose you want to print the value of each element, then we can use a for loop. So here I use a for loop to print the value of each element. So here you need to create index. The index is a variable, begins from 0. And in each iteration, the index is increased by 1. Its value is at most still the number -1. So this is the common usage of a for loop to print the values of an array inside an array. So I recommend your program should be like this, because this is standard. This is almost standard. We always use a for loop to process an array. So this is almost standard. And the benefit of using naming constant is that you don't need to modify the code if the array size is changed. For example, I add one element to this array, then you don't need to modify the for loop. You don't need to modify the for loop even if your array is changed. However, if you use constant, if you do not use naming constant, you directly write the array size, then you need to modify this number when the array size is changed. And this is also prevents you to cause index out of range, because if you write code this, index I is always within the legal range. However, if you randomly write some number here, this might cause index out of range, because if I is greater than or equal to 6, then this will cause index out of range. So you will notice after index 6, after index 5, the elements, the values of elements I are known. If you perform some operations to the array elements, here I perform +1. You notice that we have runtime error, because here the error message stack smashing detected. This is wrong. This is a type of runtime error, and the program does not finish normally. The exit code is not 0. So here we have runtime error because here the index is out of range when I is so when I is greater than or equal to student number, then this line will cause will lead to index out of range. This will cause runtime error. So you cannot you must be very careful when you use index variable. You need to ensure its range is legal. So here, if we use naming constant, then you can ensure your code. You can ensure index is within the legal range. So now the program the program is runs normally. So it is a good habit to know the range of your index. Here the range is controlled by student number. So if student number is the array size, then you can ensure the index is within the legal range. So here is one example. You can use a for loop to read user inputs into array elements. If you choose not to use the for loop, you can expand the for loop like this. But this is only for this is only for small arrays. If your array is large, for example, if your array contains 100 elements, then it is not possible to expand the for loop like this. The slides also introduce another example. This example is to find the largest value inside an array, and later I will revisit this example. So the next slide talks about the common mistake about using an array. The array index should begins from 0. For the C or C++ or many programming languages, the index always begins from 0. So the index does not begins from 1. Some programming language like MATLAB, the index begins from 1, but for C++, the index always begins from 0. And C++ does not check the index, so you need to ensure the index is within the legal range by yourself, because the compiler will not tell you whether the index is within the range. So compiler will not detect such errors. So you can compile your program, because compiler does not perform detection. So you can always So the syntax is legal. You can compile your program and obtain the machine code. However, when you run the machine code, your machine code might cause runtime error. So it's programmer's responsibility to ensure the index is stay in range. So here is another common mistakes. If you declare an array with 12 elements, then the index is at most 11. It's size -1. So a common mistake is try to assign some value at index 12. 12 is the size of this array. However, 12 is out of range. So this is a common mistake. And the compiler will show no warnings. And this is not guaranteed to produce runtime error. Sometimes your program is fine without any errors, but sometimes your program will produce runtime error. The next slide is about how to use naming constants, named constants, to declare an array. And I already introduced this convention. This style is recommended because this improves the readability of your program, and this also makes your program easy to maintain, because you can adjust the array size in this declaration. And later, when you want to modify the array size, you only need to modify this line. You don't need to modify a constant used in every for loops. The next slide is about the two syntax in C++. How to process each element. We already introduced the second one. You can use index variable to access array elements. And C++ 2011 provides you another choice. You can use range-based for loops. And for this is a new syntax. This syntax is new. And the syntax, for this syntax, you don't need to use index. You can directly access array elements. So for this syntax, you declare a variable x inside the parentheses, and this variable x will denote array elements. So here x is array elements. X is 20 in the first iteration. X is 30 in the second iteration. So for this range-based for loop, you don't need to use index variables. You can directly access array elements. And next, I will talk about how arrays are allocated in memory. And and it is actually very easy. The array is allocated sequentially. Sequentially means one after one. The second element is after the first element. The third element is after the second element. So an array is allocated sequentially, and this allows us to perform calculations to compute the memory address of each element. Here is one example about memory allocation for an array. So here I declare an array of 6 elements, and each element is an integer. Here I assume each integer takes 2 bytes. This is not true in our computer because an integer takes 4 bytes. However, this is only for illustration. So in this simple example, I assume integer only takes 2 bytes. And suppose the memory address of the first element is 23. So this is the memory address of the first element. Then you can compute the memory address of the second element. So the memory address should be 1023 plus 2, because each element takes 2 bytes. So the memory address of the second element is 1025. And you can also compute the memory address of the next element. So you perform plus 2. So 25 plus 2 is 27, because each integer takes 2 bytes for this example. And in fact, you can compute the memory address of any elements. For example, if you want to compute the memory address at the index 3, then you just perform addition to the address at index 0. So, for example, 23 plus 2 times 3 is 6. So 23 plus 6 is 29. So you can obtain the memory address at index 3. Once you know the memory address of the first element. Let's take a break for 10 minutes. Hello. Let's continue. We talk about the memory location about an array, and I will use one example to show how you can print the memory address of each element. So now suppose we want to print the memory address of some element, then you can use the ampersand operator. So this operator will returns the memory address. Follow that operator. So here I print the memory address at the index 0 and the memory address at the index 1. And you can notice the difference. The difference between the two memory address is 4 because each element is an integer, and integer takes 4 bytes. And we also know that the memory address is hexadecimal. You notice that this number begins from 0x. So this means this number is in hexadecimal number system. So you will notice each digit is the range of each digit is 0, 1 up to 15, and 15 is F. So this is a hexadecimal number. Then you can try to here we can adjust to another example. Suppose you modify the data type. For example, you modify the data type to double. Then each element, since double takes 8 bytes, so the difference between the two numbers should be 8. So you see that if I change the data type from integer to double, then the difference between the two memory address is 8. And you can try to compute the memory address at the index 5. You can try to compute the memory address. The difference between the two elements should be 5 times size of double. So the difference between the two elements should be 5 times 8, so should be 40. And you can try to print the memory address. And we notice that so you need to compute F8 minus D0. So you need to perform some arithmetic in hexadecimal system. Because F is 15 and D is 13, so if you minus F minus D is 2, and the 2 times 16 is 32, and 32 plus 8 is 40. So you see that the difference between the two memory address is 40. So because array is sequentially located, so we can compute the memory address of any element. And if you only want to obtain the memory address of the first element, you can omit the ampersand. You can use another shorthand notation. So if you only want to print the memory address of the first element, you can use the array's name. You can use scores. So this will gives you the memory address of the first element. So the two expressions are the same. You can use the array name to denote the memory address of the first element. And later we will talk more about memory address in later chapters. We will talk about pointers. Pointers deals with memory address. So we will learn more about pointers in later chapters. And you can try to print memory space outside the legal range. For example, you can try to print memory address at index 6. This is legal. You can print memory address at index 6. This is legal. So we see here the difference is 8 minus 7. So it's 1. 1 times 16. So 16 minus 8 is 8. So the difference between the two address is 8. However, if you want to modify this value, if you want to modify element at the index 6, this will cause index out of range, because 6 is outside the legal range. The index is at the most 6 minus 1. So you can know the memory address at the index 6, but this is outside the array. So if you modify its value, this might lead to runtime error. The next slide is about array initialization, and I will show you many ways to initialize an array. The first one is we can use a pair of braces to initialize an array. On the left hand side here, I specify the array size inside the brackets, and this size is the same as the right hand side. Both represents 5 elements, and you can omit the number inside the bracket if you use braces to initialize this array, because the compiler will automatically determine array size from the right hand side. The right hand side has 5 elements, so the compiler knows the array size is 5. So here I create a mismatch. So on the right hand side we have 6 elements, but the left hand side only has 5 elements. So this is a mismatch. So here we have syntax error, too many initializers. So here I print the number of bytes of this array. You can use the size of operator. This array takes 20 bytes because 5 times size of int. Size of int is 4. 5 times 4 is 20. So this array takes 20 bytes. You can also obtain the number of elements for this array. You just divide the total bytes by the size of each element. So you can use size of for the first element, and if you perform this division, you can obtain the array size. So the array size is 5. So here you can omit the number inside the brackets. So the result is the same. Because the computer can automatically determine the array size from the right hand side. And I will show you one example I saw from students' assignments, which is very dangerous. He writes code like this. He declares an array like this. Then do you know the array size of this array? He declares array like this. And the syntax is legal. So this program can be compiled. And do you know the size of this array? None. None is a number. Or so the size is none, or okay, size is none, but the size should be a number. Size should be a number. So you think size is which number? 0. Yes. So for example, if you declare array like this, its size is 0. So I saw students write code like this. However, this is very dangerous because you cannot perform any operation to this array. For example, you try to modify the value of any element. This will cause index out of range because this array has no elements. So if you perform this assignment, you will cause index out of range. So your program will your program might lead to runtime error. So if you understand array initialization, you should not declare array like this. You never use empty. So both. However, if you specify not size, if you specify array size on the left hand side, then this is legal because you tell the compiler the array size is 5. So this is fine. But you cannot omit the number inside bracket when the left hand side when the right hand side is empty. So you see that the array size is 0. Let's see the third example. This example is this example shows a mismatch between the right hand side and left hand side. The right hand side has only two elements, but the left hand side specify array size is 5. So there is a mismatch between right hand side and left hand side. And so the right hand side only specify the first two elements. The remaining three elements are not specified. And the C++ will initialize the remaining three elements to 0. So this is the rule, C++ rule. C++ will initialize the remaining side, the unspecified elements to be 0. So here we can try to you can try to perform some experiments about this rule. So here I use a for loop to print the value of each element. And so we see that the five elements is 1, 2, 0, 0. The remaining three elements are set to 0. However, if you omit the number inside the brackets, the array size is only 2. So if you print the value outside the arrays, its value should be unknown. So if you do not specify array size, so you see that here, if I do not specify the array size, then the array size is 2. Then the following for loop will try to print elements outside this array. And you see that these elements, the value are very large, are some unknown values. So it is important to ensure the index is inside the legal range. Here, if I is larger than or if I is larger than or equal to 2, then we have index out of range. So here is index out of range. And this rule will be applied to strings, to C strings, and later we will revisit this rule when we learn C string. We will learn C string in this week, and C string is also a static array. So when you want to initialize a string, then later we will use the rule, the same rule. The fourth line initialize the array to zeros. So here, if you only specify 1 0 on the right hand side, and you specify the array size to be 5, and according to the previous rule, you only specify 1 element, and the remaining 4 elements will be set to 0. So if you write this expression, this will set all the elements to be 0. So all the elements are 0. However, if you omit this brace, if you omit the brace, means you do not perform initialization, and this time the values will be some random number. So here I do not perform initialization, and you see the values are some random number. And you can also omit the 0. You can also omit the 0 inside the braces. This will also initialize all the elements to be 0. So, but this is only for C++. For C, you cannot use this syntax. If you use braces, this means you want to perform initialization, and the compiler will set all the elements to be 0. And however, it is important to remember to set the array size. Here you need to set the array size. If you omit the array size, then its size is 0. So here, if the right hand side is empty, it is important to specify array size. Otherwise, the array size is 0, and you can do nothing with this array. So when the right hand side is the empty braces, then you remember to specify the array size. Finally, we can obtain the array size by the size operator. I already show you can use this division to obtain the array size. So the right hand side and the left hand side need not to be matched. The right hand side can be less than the left hand side, so you can only specify elements less than 5 elements. But you cannot specify elements more than 5. You cannot specify 6 elements. Doing this will cause syntax error. Doing this will cause syntax error because the right hand side is larger than left hand side. So this causes a syntax error. However, it is legal to let the right hand side to contain fewer elements than array size. And the unspecified elements will be set to 0. The next slide is about some pitfall about using arrays. We can use braces to initialize an array when you perform declaration. However, after declaration, you cannot use a braces to perform assignment. So the following syntax is illegal in C or C++. So here you can use a pair of braces to initialize an array. However, you cannot decompose this statement into two statements. You cannot assign one. You cannot use a pair of braces. You cannot assign this initializer to an array. This is syntax error. This causes syntax error. So you cannot use initializer list to perform assignment. You can only do this for in declaration. So you can only do this in declaration. This is counterintuitive because this is does not follow our intuition. But this is the restriction of the C++ programming language. If you want to bypass this limitation, you should consider another data type, such as vector, or other data type in the standard template library. So if you want to use the built-in library, you cannot perform assignment like this, because this is a restriction of the programming language itself. And similarly, you cannot assign one array to another array. In this example, we already declare an array. And later, in the next statement, we want to declare another array. And you cannot use the previously declared array as the initial value. This also leads to syntax error. So when you want to when you write statement like this leads to syntax error. So here is the error message. the array must be initialized with a brace enclosed initializer. So you can only use a pair of braces to initialize an array. Here we want to perform copy, or we want to copy the contents of one array to another array. Then if you cannot do assignment, then what will you do? If you cannot perform assignment, array assignment, how do you copy the values from one array to another? So we cannot write statement like this. We can only declare So now suppose I want to copy the first array to array temp. Then how can you perform the copy? You can always use the for loop. You can always use the for loop to perform element-wise copy, like the following. So if you want to perform array assignment like this, you cannot directly use the assignment operator, and instead you need to use the for loop to perform element-wise copy. This is tedious because it requires you to write a for loop. But if you choose another data type, such vector, then the data type allows you to use assignment for array copy. And we have finished the introduction to arrays. The second part is about how to combine arrays and the functions. So we will learn functions first. So we will proceed to the next chapter, which introduce functions. After we learn functions, then we will return to this part. So let's see the next chapter. The next chapter is about function basics. Sorry, here I forgot one example. We have another example. This example is to find the largest element in an array. So you can try to you can try to implement this. You can try to implement the algorithm by yourself. Given one array, can you write code to find the largest element? So now suppose we have an array with 5 elements, and you want to find the maximal. You want to find the maximum, and this array can be changed. So the contents of this array can be changed. Then can you write? Can you implement the algorithm to find the maximum elements. So here is the implementation. The following, here I declare a variable max score, and I initialize the max score to be 0. Then I create a for loop to access each element. Then I compare this element to the max score. If max score is smaller than the element at the index I, then I will perform assignment. I will assign the element at the index I to max score. So this will update the max score to be the maximum elements in this array. So you can use the for loop to find the maximum elements in an array. So the maximum elements is 5, and you can change the array, and you don't need to modify the code. So here I change the contents of this array, and the code can still find the maximum elements. And usually we recommend to use named constants, because here you can replace this array size to be a named constants, and this will be easier for you to maintain your code. The current implementation has some problem. You need to carefully determine the initial value. If you choose too large initial value, then you cannot find a maximum number. For example, if the initial value is sorry, I changed the if your initial value is 10, then you cannot find the maximum number, because no element can be larger than max score. So we should be pay attention to the initial value of max score. You should choose the proper initial value, and this will cause one problem. How do we determine the initial value of this variable? It is better if the algorithm can automatically determine this initial value, then we don't need to worry about the initial value. So do you have any other idea how to choose the proper initial value for max score? actually you can let the initial value to be the first element. So here I let the initial value to be the first element, and this is reasonable because the maximum elements is inside this array. So it is reasonable to choose the first element as the initial value of max score. And for the following for loop, you can modify the initial value of index I. You can change index I. You can begin index I from 1, because we already see the first element. So here you can begin from index begins from 1. And in this way, you can also find the maximum value of this array. And you don't need to worry about the initial value of max score, because the initial value of max score is the first element. So you don't need to worry about how to initialize max score. So this implementation is clever than the previous one, because this implementation does not require you to determine the initial value of max score. So this implementation is better. And this implementation is the one shown in the slides. So this is the common implementation when you want to find the maximum element in an array. And actually, for this example, we have you might test other examples. For example, if this array has two elements, two maximum elements, suppose suppose this array contains 6, and the 6 is maximum elements. And your code will find the maximum number and also the index for this maximum number. So, for example, the index for this maximum number is 2, while the index for the second maximum number is 5. So their index is different, although the value is the same. So can you determine after the code which maximum will you find, the first maximum or the second maximum after this for loop? What you find is the first maximum or the second maximum. So if you use such implementation to determine the maximum number in this array, then which maximum will you find for this example? So the answer is the first maximum or the second maximum. So here I modify the code. I create additional variable max index. So max index will be the index for the maximum element. So after the for loop, what is the value of max index for this example? It's 2 or 5. So after the for loop, max index will be 2 or 5. 2. Okay. Yes, I think the answer is also 2. Yes, if you run the code, you find after the for loop, max index is 2, and max score is 6. Because here we use less than. So the two variables will be updated only when max score is less than scores at the index I. So if I is 5, this if statement will not be executed because max score is 6. 6 is not smaller than 6. So the if statement will not be executed at this line. Of course, if you want to obtain the second maximum, it is possible. You just modify your implementation, then you can obtain the modify your implementation to obtain the second maximum at index 4. And time is up, so we can now dismiss.